to the second class on rational numbers. In our first class, we discussed closure property. Today, we are going to discuss commutative property of rational numbers. First of all, let us discuss about whole numbers. I have drawn a tabular column under which I have written the operations. First of all, we are going to check whether whole numbers obey commutative law. We are going to check for any two numbers A and B, is A plus B is equal to B plus A. That is commutative law. Okay, so take any two whole numbers. Let me take the whole number 0 itself. 0 plus 3 is equal to 3. Now take the same two numbers. This is A and this is B for you. Now add B plus A. That also gives you 3. From this, what did you understand? You understood A plus B is equal to B plus A. So what do you say? Addition is commutative. Clear? Come to subtraction. Let us take the same two numbers. 0 minus 3 gives you negative 3. Because from 0 you are subtracting a negative number. Now let us subtract 3 minus 0. What do you get? You get positive 3. From this, what did you say? Here you can say subtraction is not commutative. Subtraction is not commutative. Let us think about multiplication. Let me take 6 and 3. 3 into 6 is equal to 18. What about 6 into 3? That is also equal to 18. So what can you say? Multiplication is commutative because we got A into B as equal to B into A. Last one, division. Take the same two numbers 3 and 6. Let me divide 3 by 6. 3 divided by 6. What will you get? You get 1 by 2. Whereas 6 divided by 3 gives you 2. Here what did you understand? A divided by B is not equal to B divided by A. So we can say division is not commutative. Clear, children? Now let us check the same property for integers. You know integers are nothing but 0, positive numbers and negative numbers. I have written here. So addition. Take any two integers. I am taking minus 2 and 3. I took a negative integer and a positive integer. Negative 2 plus 3 gives you 1. Now let us add 3 plus minus 2. Then also you get 1. Isn't it? So what can you say? Addition is commutative in the case of integers. Come to the second idea, subtraction. Take the same two numbers. I took minus 2 from which I am going to subtract 3. From minus 2, if you subtract 3, what do you get? You get negative 5. Why do you get negative 5? Same sign for both numbers. So add and write same sign. Now let us subtract minus 2 from 3. From 3, if you subtract minus 2, what do you get? You get 3 plus 2, which is equal to 5. So what can you say here? Subtraction is not commutative. What about multiplication? Minus 2 into 3 gives you negative 6. Also 3 into negative 2 gives you negative 6. So you can say multiplication is commutative. because A into B is same as B into A. What about division? If you divide a integer, take for example -2 divided by -4. What do you get here, children? -2 divided by -4 gives you 1/2. Whereas -4 divided by -2 gives you 2. So here A divided by B is not equal to B divided by A. So we can say division is not commutative. Let us check the same property in the case of rational numbers also. Children, to check the property for rational numbers, let us consider like fractions so that you will understand more easily. Let me consider two like fractions, that is 2/7. Let me take another fraction as 3/7. Now when you add 2/7 and 3/7, what do you get? Since denominators are same, write the same denominator. 2 plus 3 gives you 5. Now let us add 3/7 plus 2/7. Then also you get the same answer. So what can you say? Addition is commutative. Come to subtraction. 2/7 minus 3/7. Denominator is 7. But look at the numerator. From 2 you are subtracting a larger number 3. So you get -1 in the numerator. But what is 3/7 minus 2/7? You are going to get 1/7. So what can you say? In this case, it is not commutative. Come to multiplication. Let us use the same two fractions. Multiplication. 2/7 into 3/7 is same as 3/7 into 2/7, isn't it? Because in both you get the same answer. You get 2 3s are 6. 6/49 in the first case, 6/49 in the second case also. So we can say yes, it is commutative. Multiplication is commutative. What about division? Take the same two numbers, 2/7 divided by 3/7. What is the answer here? Whenever you divide, what we have to do? We multiply with the reciprocal. So we get 2/7 into 7/3. 7 and 7 cancels. You get 2/3 as the answer. Now let us divide 3/7 divided by 2/7. What do you get? 3/7 into 7/2. 7 and 7 cancels. You get 3/2. Here you are getting two different answers. So you can say division is not commutative in the case of rational numbers. Children, in our next class, we will discuss about the next property, that is associative property. Let us look at the role of 0 and 1. Okay, see this number 0 has got a peculiar property. Whatever number you add to 0, you get back the number. For example, if you add a number -1 added to 0, you get back -1. And take another number. Let us consider a positive number. 3 added to 0 gives back the number 3 itself. So we call 0 to be the additive identity for all rational numbers. 0 is the additive identity for all rational numbers. Come to the role of 1. Whatever number you multiply by 1, you get back the number itself. Take a fraction, for example, 2/3 into 1. You get back 2/3. Let us consider a negative rational number. Let us consider minus 3 by 2. Let us multiply it by 1. What do you get? You get back the number. So we call 1 to be the multiplicative identity for all rational numbers. Hope you understood my class.